Imagine a spacecraft traveling billions of miles through space to a distant asteroid to collect a precious sample that could hold the key to the origins of life on Earth. Imagine a world where we can travel to the stars, where we can explore new planets, and maybe even find life beyond Earth. That world is one step closer thanks to the OSIRIS-REx mission. Hey everyone, I am a space enthusiast like you, and you are watching AstroYonder. Welcome to my video on the OSIRIS-REx mission. The OSIRIS-REx mission is the first US mission to return samples from an asteroid, and it's one of the most exciting, ambitious, and daring space exploration missions ever undertaken of our time. In this video, I'm going to tell you everything you need to know about the OSIRIS-REx mission. I'll cover the following. What is the OSIRIS-REx mission? What is the asteroid Bennu? Why is Bennu so important to study? How did the OSIRIS-REx spacecraft collect a sample from Bennu? When will the OSIRIS-REx sample return to Earth? What will scientists do with the OSIRIS-REx sample? So if you're interested in learning more about this groundbreaking mission, stay tuned. The OSIRIS-REx, short for Origins, Spectral Interpretation, Resource Identification, Security Regolith Explorer, is a NASA-led robotic space exploration mission to study and collect a sample from the asteroid Bennu and return it to Earth for detailed analysis. The mission is the first US mission to return samples from an asteroid. Bennu is a carbonaceous asteroid, which means it is rich in organic matter and water. Carbonaceous asteroids are thought to be the building blocks of planets, so studying Bennu can help us to understand the origins of our own solar system. OSIRIS-REx was launched in September 2016 and arrived at Bennu in December 2018. The spacecraft spent 2 years studying Bennu from orbit, mapping its surface and collecting data on its composition and potential sample sites. In October 2020, OSIRIS-REx descended to the surface of Bennu and collected a sample of regolith, or loose surface material. The OSIRIS-REx spacecraft is now on its way back to Earth and is scheduled to arrive on September 24, 2023. When it does, it will release the sample capsule into the atmosphere, where it will parachute to a safe landing in the Utah desert. The OSIRIS-REx sample is the largest asteroid sample ever returned to Earth. It will be studied by scientists all over the world to learn more about the origins and evolution of our solar system. In August 2018, OSIRIS-REx began its approach phase. Its long-range camera captured the first visible light images of Bennu, initially a single pixel moving against a backdrop of stars. Over the subsequent months, Bennu transformed from a pixel into a world, revealing its shape, rotation, and color for the first time. Now, after pursuing its target for over 2 years, OSIRIS-REx is set to arrive at asteroid Bennu on December 3rd. It will fire its thrusters to match Bennu's velocity and initiate its preliminary survey. OSIRIS-REx will pass high above the equator and the poles, measuring Bennu's position and mass while refining its size, shape, and spin. On New Year's Eve, OSIRIS-REx will venture close enough to be captured into orbit by Bennu's minuscule gravity, marking it as the smallest world ever to be orbited by a spacecraft. In early 2019, OSIRIS-REx will break orbit to conduct a detailed survey of Bennu. It will begin with a mapping campaign named the Baseball Diamond, observing Bennu at different latitudes and times of day. Using its mapping camera, laser altimeter, and 2 spectrometers, OSIRIS-REx will capture stereo images and identify large rocks on the surface that could pose a hazard later in the mission. In its second mapping campaign, OSIRIS-REx will observe Bennu from 7 different stations around its equator. At each station, it will take measurements from pole to pole, utilizing its mapping camera, laser altimeter, and spectrometers. The combined data will provide a detailed view of Bennu's geological features and composition, enhancing navigational accuracy and guiding mission planners in the search for suitable sample collection sites. Following the detailed survey, OSIRIS-REx will re-enter orbit at a radius of only 1 kilometer. Orbit B will serve as the mission's safe home orbit until sample collection. During this phase, OSIRIS-REx will globally map Bennu, flying in a polar orbit as the asteroid rotates beneath it. This will enable complete coverage of the surface. Orbit B's precession, or wobble, will also be utilized to measure Bennu's gravity field and account for non-gravitational forces gradually altering the asteroid's trajectory. In mid-2019, OSIRIS-REx will commence its reconnaissance phase, breaking orbit and flying over 4 candidate sample sites at a distance of 225 meters. This close approach will reveal large pebbles that could pose a hazard during sample collection. Mission planners will use this information to select the 2 best sites for further inspection at a range of 525 meters. OSIRIS-REx will fly over the 2 final candidate sites, spectrally mapping the surface to reveal its chemical composition. This data will assist mission planners in determining the most valuable site for collecting the sample. Once the final site is chosen, OSIRIS-REx will begin its rehearsal phase. This will involve practicing autonomous flight to predetermined checkpoints, including the match point where the spacecraft will lower to within 30 meters of the surface, matching Bennu's speed and rotation for safe sample collection. In mid-2020, OSIRIS-REx will be prepared to collect a sample of Bennu. Prior to descent, the spacecraft will deploy its touch-and-go sample acquisition mechanism, TAGSAM, a new technology developed for the mission. At the checkpoint, OSIRIS-REx will initiate its final descent, pulling back its solar arrays for safety. As TAGSAM touches down, it will release high-pressure nitrogen gas into the soil, stirring up loose material. A filter within the sample head will trap rocks and dirt while allowing the gas to escape into space. Once the sample is secured, OSIRIS-REx will fire its thrusters and move away from Bennu, retreating to a safe distance with its precious cargo. Following collection, OSIRIS-REx will verify the status of the sample using a camera called SAM-CAM. This visual inspection will ensure that no large debris is still attached to the sample head, which could pose a hazard during stowage. Next, OSIRIS-REx will confirm the mass of the sample. It will fully extend its TAGSAM arm and perform a spin maneuver to measure the change in inertia, determining the sample's mass. If at least 60 grams have been collected and the sample head is clear of hazardous debris, mission planners will instruct the spacecraft to stow the sample. STOCAM will monitor closely as the sample head enters the return capsule and is secured in place. OSIRIS-REx will then detach the TAGSAM arm from the head, seal the sample return capsule, and prepare for its journey back to Earth. Once the OSIRIS-REx sample capsule lands in the Utah desert, it will be retrieved by NASA and transported to the Johnson Space Center in Houston, Texas. There, the sample will be carefully opened and processed to ensure that it is not contaminated with Earth materials. The OSIRIS-REx sample will then be divided into 2 parts. One part will be stored in a pristine condition for future generations of scientists to study. The other part will be made available to scientists around the world for immediate study. Scientists are planning a wide range of studies on the OSIRIS-REx sample. They will be looking for evidence of organic matter, water, and other essential ingredients for life. They will also be studying the sample's composition and structure to learn more about how asteroids form and evolve. One of the most exciting aspects of the OSIRIS-REx sample is that it may contain material that is billions of years old. This means that scientists could study the sample to learn about the early solar system, when Earth and the other planets were still forming. The OSIRIS-REx sample is also expected to provide new insights into the potential for life beyond Earth. Carbonaceous asteroids, like Bennu, are thought to be rich in organic matter, which is the building block of life. Scientists are particularly interested in studying the OSIRIS-REx sample for amino acids, which are the building blocks of proteins. If amino acids are found in the OSIRIS-REx sample, it would be strong evidence that asteroids could have played a role in the origin of life on Earth. It is also possible that asteroids could have delivered organic matter to other planets and moons in the solar system, making them habitable for life. The success of the OSIRIS-REx mission paves the way for future missions to return samples from Mars, the Moon, and other objects in the solar system. On November 11th, 2019, students and researchers working on NASA's OSIRIS-REx mission made an unexpected observation: the detection of a black hole 30,000 light-years away. The detection was made by an instrument about the size of a shoebox. This is REXIS, the regolith X-ray imaging spectrometer. It was proposed and built by teams at MIT and Harvard, and was originally designed to determine the abundance of elements on the surface of asteroid Bennu. RExus contains a mask with a known pattern of open and closed holes. As X-rays pass through these holes, the mask's shadow shifts as it hits the sensor. Based on this shifting, scientists can determine where the X-ray signals came from. While OSIRIS-REx was observing the asteroid several million miles from Earth, it detected X-rays radiating from a point off the asteroid's edge, at a place where no previous object had been cataloged. This glowing object turned out to be a newly flaring black hole X-ray binary. As matter from an orbiting star is pulled onto a spinning disk surrounding the black hole, an enormous amount of energy, primarily in the form of X-rays, is released in the process. This black hole was discovered just a week earlier by Japan's MAXI telescope on the International Space Station. Also on the ISS, NASA's Neutron Star Interior Composition Explorer telescope, NICER, identified the X-ray blast a few days later. Earth's protective atmosphere shields our planet from X-rays, so these types of blasts, like the one emitted from this newly discovered black hole, can only really be observed from space. And for the first time, we made this detection from interplanetary space around an asteroid. The return of the OSIRIS-REx sample to Earth in September 2023 is a highly anticipated event, and scientists around the world are eager to begin their studies of this precious cargo. The OSIRIS-REx mission is more than just a scientific endeavor. It's also a testament to the human spirit and our insatiable desire to explore. So there you have it. Everything you need to know about the OSIRIS-REx mission. Now I know what you're all thinking, but what does this mean for me? Well, for one thing, it means that we're one step closer to understanding the origins of our solar system and the potential for life beyond Earth. But until then, be sure to subscribe to my channel for more videos on space exploration and other cool science topics. And don't forget to leave a comment below and let me know what you think about the OSIRIS-REx mission.